Hello and welcome to another edition of Math is Still Math. Alright, 7th grade, we're talking about 7GA1. Basically, you need to understand how scaling works. You can draw something big and then draw something small or vice versa. And we use factors to make sure that those items, those features, are exactly the same except miniature or larger. I got some great pictures here. We got an art installment of this giant clothespin. However, we all know clothespins are really small, but look at the detail. It is so exact. You know exactly what it is, even though it's enormous. And then, of course, when it comes to artwork of the human body, there's a lot of scale and ratio that is very, very uniform because of our DNA. And though each person's a little bit different, generally speaking, we do have a lot of features that follow those proportional parts of our makeup. Of course, can't leave without Derek Zulander's Center for Kids Who Can't Read Good. He smashes the building because he thinks it needs to be at least 3 times bigger than the way it is for students to go inside. But let's go ahead and start talking about what this means to you as a student in your math class. So here we have a very, very basic scale ratio problem with geometric figures. You're being asked to solve for x. The first thing you need to realize is that these are called similar shapes. That is a very important word in geometry. Similar means that the two shapes share a lot of characteristics. They're almost like twins, except one is either smaller or larger than the other. But those changes in size are proportional to all the features that make them individual shapes. So what we are going to do is follow a very simple 3-step method to find our missing side length. So step number 1, we need to find corresponding features, like, information that the problem just gives us. So let's talk about what we can find. This here. Alright, you're going to notice that this 12 and this 3 are on the same corresponding side. That word down here, corresponding. They're on the same corresponding side of their respective shapes. So that's where this problem is going to unlock. How do I go from 12 to 3? That's the question. How do I go from 12 to 3? It's like we need to create our own little problem here. 12 times blank equals 3. That's what we're trying to figure out, because that is going to give us part 2, the scale factor. So step 1, you just have to recognize that 12 and 3 are corresponding elements of these shapes. Step 2 is that you gotta figure out how you get from one to the other. Now, it's really easy to say that 12 divided by 4 is 3. You gotta level up your understanding of factors here. We have to do multiplication. So instead of saying divided by 4, let's say multiplied by 1/4. I'm splitting here. It's basically the same thing. 12 divided by 4 is 3. 12 times 1/4 is 3. They're the same procedure. This is why in the order of operations, multiplication, division go left to right, because essentially they're the same. Excuse me. So, if you can figure out the scale factor between the 12 and the 3, you can unlock the rest of the shape. We're going to do the same thing, go from 20 to the x. So 20 times 1/4 will equal x. Okay, well, 20 over 1 times 1 over 4 would be 20 over 4. And that's just the division problem. What's 20 divided by 4? 5. That means that x equals 5. So we identified the corresponding features, the 12 and the 3. We figured out the scale factor that goes between them, which is 1/4. And then we use the scale factor to discover the other feature that we were missing. That is how you unpack these problems. Let's do another one together before you try one. Okay, let's do this one together, and then the next one I want you to try it before I show you how to get the answer. Step 1, what are the two sides that correspond to each other in these shapes? What is the information they're giving us to unlock this problem? Well, I'm going to notice right here, this side length and this side length are corresponding to basically the same side of two different shapes, but they're similar. Therefore, they're connected by a scale factor. So, how do we get from here to here? How do we get from 3 to 1? Again, that is a multiplication problem. Write it down. So 3 times blank equals 1. Now, for those of you that notice that division would solve this, 3 divided by 3 would equal 1. Let's just rewrite it as multiplication. 3 times 1/3 is going to be equal to 1. That's your scale factor. The scale factor in this problem is 1/3. So, to get our answer, all we need to do is do the same thing. Go from the 9 to its corresponding feature, which is x. So 9 times 1/3 will be equal to x. That's all we gotta do. So that'd be 9 over 1 times 1 over 3. So you get 9. That's really bad. 9 over 3. That's a division problem. Well, 9 divided by 3 is 3. Therefore, x equals 3. So, identify the corresponding features, figure out what the scale factor is. By the way, if you can figure it out as division, just write it as the multiplication of the fraction form. And lastly, use that fraction or use that scale factor to figure out what is missing, what they're asking for. So on the next one, I want you to pause it and see if you can figure it out before I solve it. Okay, here you go. I want you to solve for x on this problem. Follow the step-by-step procedure. Identify the features that correspond where they give you information. Use reasoning to find out, write a little equation, figure out what the scale factor is. How do I go from one to the other? And then take that information and apply it to the other features so you can figure out what's missing. So pause it now, and we'll see if you got it right. Okay, so now you either finish the problem, you want to see if we get the same answer, or maybe you got halfway through and didn't know what to do next. That's fine. So let's let's just go ahead and crack this one. First, delete you. Okay. Let's see. Alright. So, the corresponding features they show me that I can use are this side and this side. Okay? Now, for me to go from 16 to 4, 16 times blank equals 4. That's what I gotta start with. And the reason I have to go that direction is because I gotta go from 8 to x. So that means that 8 times this thing is going to equal to x. My expert hit right. Okay, so, well, I get it. 16 divided by 4 is 4, so therefore to write it as a multiplication problem, I would say 16 times 1/4 is 4. Therefore, I'm going to use the same scale factor. For this, 8 times 1/4 would be x. Now, that's going to be 8 over 1 times 1/4, so that'd be 8 over 4. That's an 8. So 8 times 1 is 8. 1 times 4 is 4. 8 divided by 4 is equal to 2. That means that x equals 2. If you got it, give yourself a pat on the back. Great job. Let's do one more before we move into another type of problem using these same skills. Again, you should pause and try to solve this one yourself. So just figure out what x is, or get as far as you can until you need help, and then unpause it, and let's see if we get the same answer. Okay, here we go. Step 1. Let's find my brush. Alright, so the corresponding features are going to be, let's see, this 4 and this 8. Perfect. Okay. In this one, I need to figure out how I get from 4 to 8, because I'm going to have to get from 5 to x in the end. So my number sequence would be 4 times blank equals 8. That would mean that 5 times the same thing would equal x. That's what we're doing. So 4 times 2 is equal to 8. Therefore, 5 times 2 equals x. 5 times 2 is 10. So I guess x is equal to 10. That's using the scale factor. If you got it right, great job. Now, these were the most basic problems you can get as a 7th grade math student. What we need to do now is try to take this skill and apply it in a few different ways. Let's try some con lessons. So here's your first con lesson for the week, or you know what, you do them in any order you want, but here is put that on camera. Here we are with identify scale factor in scale drawings. It's the same skill, it's the same part of your brain that we were just practicing, but it is presented a little differently. So if I take out my pen here and mark this for you so it's easier to see, we are going to try and figure out what the scale factor is between these two shapes. So basically, since they tell us if figure B is a scale copy of figure A, we know that they're similar shapes. So just pick a side. So the distance here is 1, 2, 3, 4, 5. Wow, my handwriting is awesome. 6. So that's 6 units, okay, for figure A, compared to 1, 2 units for figure B. Now, the key here is you have to listen to the direction the words tell us to go. What is the scale? We're going from A to B. And that'll be the difference between whether we are multiplying by 3 or if we are multiplying by 1/3. Okay? So since we're going from the big shape to the small shape, it's 6 times 1/3 that'll get us to 2. So my answer is going to be 1 /3 for 1/3. Or at least it should be. Ah, nice. Let's try another one. So here we go. Figure B is a scaled copy. Okay, so basically right here, they're telling us that they are similar shapes. That's why they had to say this. What is the scale factor from A to B? Okay, we're going from A to B. It said it right there. That's really important. Now we can pick any side length we want. So if I want to go from 7 to 28, I have to multiply by 4. If I'd been going the other way, I'd be multiplying by 1/4, but I'm going from the small one to the big one, so I would just say 4. That's it. So that's how you identify scale factors in this lesson. Let's try another one. Okay, so interpreting scale factor in scale drawings. So there's some very specific language here it's asking you to understand, and it's right here. So read these directions. Olivia made a scaled copy of the following triangle. She used a scale factor greater than 1. This is the sentence you need to focus on. Okay. Anytime you use a scale factor that's greater than 1, you're going to get a bigger shape. Anytime you multiply by something that's bigger than a whole number, you are going to increase its size. Like in the last few problems, whenever we multiply by a fraction, we end up with a smaller triangle or a smaller shape. Well, this is the inverse of that. We're multiplying by something that's greater than 1. So it has to be bigger. What could the height? Okay, so they're talking about the height, which is here. What could the height of the scaled copy of the triangle? Okay, what could be the height of the scaled copy of the triangle? Okay, well, if we're multiplying by something greater than 1, it would have to be bigger than 11. So that's out. It won't let me cross, so that's not it. That's not it. It could be either of these. Oh, choose 3 answers. Oh, look at that. There's more down there. Okay. Well, bigger than 11 would include this one, and this one. So the reason I know those are the answers is because it says use a scale factor that's greater than 1. So 11 times something that's greater than 1 could be one of these 3. Sweet. So this one says he used a scale factor greater than 1. Jing Shang made a scaled copy of the following rhombus. Okay. What could be the side length of the copy? Okay, first of all, sidebar. Okay, a rhombus. This would include squares. Rhombus are 4-sided polygons, and every side is the same length. So if I just count one of the sides, I'm really counting all of the sides. So let's see. So 1, 2, 3, 4, 5. Okay, so every side length is 5, right? That's the definition of a rhombus. He uses a scale factor greater than 1, which means if he's multiplied by something that's greater than 1, he should end up with side lengths that are larger than 5. What could be the side length of the scaled copy of the rhombus? Well, too small, the exact same, which is, no, it said it has to be greater than 1, so it can't be 5. It says choose, well, these are the only two that are bigger. If I multiply them by something greater than 1, they would have, like, these could be, they could be it. There it is. So that's how you interpret scale factors. If they said less than 1, you need something smaller than 5, but they didn't. They said greater than 1. Let's try another lesson. Okay. This problem is deceivingly complicated. Unless you're very familiar with fractions, which you should be. But I'm going to get you through this, even if the fractions can be a bit of a headache. So, step 1, we're going to realize that the corresponding features are this 4 and this 3, okay? So we're going to use these to start our problem. Because we need to solve for x, we're going to be going in this direction. So I need to figure out how to get from 4 to 3. And the way we're going to do that is just a little bit of division. So what is 4 divided by 3? Now, if you put this in a calculator, you're going to get a never-ending repeating decimal. So we're just going to leave it as a fraction for now. 4 divided by 3 is just simply 4/3. Okay? Okay. Just accept that for now. 4 divided by 3 is just 4/3. Which means the scale factor that goes in between these is 4/3. If you're going the other direction, that is. Remember when I said if you're going from bigger to smaller, you multiply by the inverse? Well, that means you need to multiply by 3/4. That's how you get from 4 to 3. If 4 divided by 3 is 4/3, you multiply by the inverse. So 4 times 3/4 is 3. So what's 7.2 times 3/4? Now that, they go ahead and give you a calculator button. So here's what we're going to do. We'll take 7 and 2/10, that's 7.2. We'll multiply by 3, and we'll divide by 4. And it gives us 5 and 4/10. And that's the correct answer. Let's do another one, because that can be a little intimidating for people that really struggle with fractions. Figure A maps. Okay, so here's another vocab term that they're throwing at you. Figure A maps. That's their way of saying they're similar shapes. So figure A maps to figure B with a scale factor of 2.5. Okay, so we go from A to B with a scale factor of 2.5. Okay. So what is the value of x? Okay, so that means that, okay, they're saying that x times 2.5 equals 5, because those are the corresponding sides, right? Something times 2.5 equals 5. Okay, well, the other way to say that would be that 5 divided by 2.5 is going to equal to x. Yeah, that's the fact, family. 5 divided by 2.5 is going to be equal to x. Okay, so this is where we're going to jump right back into just those wonderful 6th grade and 7th grade fraction skills we all love to use. Division of a fraction means you multiply by the inverse. That's what we just did in that last problem. So this would be 5/1 times, okay, sidebar, 2.5 as an improper fraction. 2 times 2 is 4, plus 1 is 5. This is equal to 5 halves. Okay, so again, we're multiplying 5 over 1 times the inverse. We gotta flip this upside down because dividing by a fraction means you multiply by its inverse. So we 5 over 1 times 2/5. So 5 times 2 is 10. 1 times 5 is 5. 10 divided by 5 is equal to 2. So that's what X should be. And it is. So figuring out the scale factor is great. But then if you're going from the big one to the small one, you have to divide by that scale factor. And if it's a fraction, that means you multiply by its inverse. Don't worry, you can do this. You can do this. And on Khan, you can actually go down and take step-by-step solutions to help out with that process. I hope this video has been instructive and helpful. Leave messages, contact me if you need extra help or more examples. Just remember, the math is still math. Well, you stuck it out for the entire video. Here's a treat just for those of you that decided to wait for the post-credits like it was some sort of a Marvel movie or something. Please enjoy.
Let's get back to the reason that we're really here. Without much further ado, I give you the Derek Zoolander Center for Kids Who Can't Read Good.
What is this?
A center for ants? What?
How can we be expected to teach children to learn how to read if they can't even fit inside the building?
Derek, it's just a small...
I don't want to hear your excuses! The center has to be at least 3 times bigger than this.
He's absolutely right.
Thank you.